So recently, somebody sent me a lot of questions on binomial theorem, and one of these questions was this thing. So you have to figure out what this series actually is. So the question before that, well, that question was easily doable um, using just algebra, normal stuff, nothing that complicated. But this, right? Try it out. It's not that straightforward. It, yeah, I mean, I just stuck on this. I didn't know what to do. But yeah, now I do. So, and the more fascinating thing is that there's like really just nothing written about this anywhere on the internet. I searched with everything I could, but yeah, I found nothing. And then I just had to sit and think about it really hard. Is there some smart way of doing this? And turns out, yeah, there is. I never thought I would have to do this, but yeah, okay. Hear me out. I'm gonna use this thing. Negative, and I know, I know it's gonna be weird, but like okay, negative NCR. So we are now allowing negative numbers in the binomial coefficient. You might think, okay, it's not that weird. We already do that, right? For the general binomial theorem, we always do this, right? We do, but we are purposefully going to convert all of these positive n values to negative n values. Right now, this might seem like, why do we want to do that? That's not going to do anything. It's just going to make this a lot more complicated, right? What's even the point of doing this? But you will see by the end of it what point it has, right? So the identity that I'm talking about is, so negative NCR, that thing can be written as negative 1 power r and then n plus r minus 1 CR, right? And now let's use it for some few cases. So first you want this 7C0 to be right represented like this. Oh, and by the way, what this means is that you can also write n plus r minus 1 CR as negative 1 power r negative n CR. All right, so now let's do this for some few cases. First you have 7C0, right? That's the first binomial coefficient that you have. We are going to convert all of these positive coefficients to negative coefficients, right? uh, and our main aim is to make the n values constant so that we can figure out something, because right now these are all changing. We don't want them to be like that. We want the n values to be constant. So 7C0, that can be written as 8 plus 0 minus 1 C0, and then using this rule, right, this rule, we can say that this is going to be equal to negative 1 power 0, which is just positive 1, and that times negative 8 C0. All right, and then 7C1 using the same thing. So 8 plus 1 minus 1 C0, that can be written as negative 1 power 1 times negative 8C1. So it's going to be negative of negative 8C1. And then 7C2. Now you see what, oh, it's not supposed to be 7C2. It's supposed to be 8C1 over here, right? Yeah, only then you will have 8, right? That's why. And then you got 9C2. So 8C1, 8C1, 9C2, 9C2. That's why I'm doing this. So 9C2, that can be written as 8 plus 2 minus 1 C, and it's not 0 by the way, it's just 1. You got 2 over here, which is going to be equal to, so positive because negative 1 power 2, and then it's going to be negative 8 C2, and now you can see what the pattern is going to be. So basically, right, so basically 7 plus R C R, that can be written as 8 plus R minus 1 C R, which is negative 1 power R, and then you got negative 8 CR, right? And I'm using this to make these guys. Okay, and the next thing, you also want these guys, right? Because they also have variable n values. Wherever you have variable n values, first of all, quickly convert them to fixed n values using this thing. All right, so 15C8, that can be written as 8 plus 8 minus 1 C8. Now why this 8? Because the R value, right? So it's going to be negative 1 power 8 times negative 8 C8. So that's just negative 8 C8. And you can see it's going to be alternate positive negative as R changes, right? And then next you have just 16 C8, which is 8 plus, I guess it's wait, is that, no, it's not 16, it's 14, sorry. So you got 8 plus 6 minus 1 is that, no, 7 minus 1, because 8 plus 6. So 7 minus 1. And then you got C 7. That's 7 right here, because, yeah. Right, so it might be hard to figure out how this is actually going to work exactly, but yeah, just write down this thing and see if this somehow matches, and hopefully something nice will come out. So 8 plus 7 minus 1, C7, that's going to be negative 1 power 7, and then you got negative 8 C7, but negative 1 power 7 is negative, that's why this thing, and so on, right? So the next one is going to be negative 8 C6, I guess, right? Yeah, I think so, because then it's gonna be like 13 C6, and that's why, right? And then you got positive over here, and so on, right? And now multiply these together. So yeah, just positive is gonna be positive, and then it's gonna be negative 8C0, negative 8C8. Next, you got a negative over here, that's negative over here. But now these two negatives will multiply to become positive. So you got negative 8C1 and negative 8C7, right? Next you're gonna have a positive from there, and you can see like all the negatives will cancel out while multiplication, right? Only these ones will remain, so which were already in the series, right? Okay, so erase that, right? And the next two combined, so 9C2 14C7, right? Oh, 9C2 13C6, fine, that's gonna be this guy and that guy. And just keep on going like that, right? Sure. And yeah, I mean, I just put a dot over here so that, you know, like whenever it's gonna terminate at that point. We don't have to worry about that. So these are like increasing. Eventually you will get to 7, right? Then it's gonna become 15C1, I guess, right? That's when this will terminate. So 7C7, sorry, no, not 7C7, wait, okay, this is also increasing, so it's like 8C1 and so on. Right, okay, so these won't go away. What about these guys? 15C8, 14C7, 13C6, right? Keep on going. So eventually, okay, you got subtracted 7s, like, okay, 8C1, and then it's going to be 7C0, and after that it's going to be like negative and whatnot. So yeah, 6C negative 1, something like that, right? Sure, which is 0, isn't it? Yeah, because the R value doesn't go in the range 0 to 6, and that's why it's supposed to be 0. And using this thing as well, so what are we talking about? We're talking about negative 6C, oops, not negative, just 6C negative 1, that's gonna come eventually, right? So for that, you are going to write it as something like minus 1 minus 1, it's going to be 8 minus 1 minus 1, C minus 1, which can be written as negative 1 power negative 1 is just negative, and then you will have negative n's, like, okay, negative 8, and then you got C, and then R, so something like that. And I guess it's going to be 0, because, right, so this thing is in negative 1, doesn't make any sense. I think it's supposed to be 0, like this is supposed to be 0, that's also supposed to be 0, right? And yeah, sure, I mean, like this just won't ever come. As you can see the pattern, it won't come at all, because this was actually supposed to be over here, and yeah, it cannot come. That's the main thing. So you don't have to worry about those kind of things, just have to go for this guy. So it keeps on going, and right, I mean, eventually gonna terminate that at some point. We don't know when that will happen, but assume it happens. And now let's think about it. What does negative 8C0 represent? It represents the coefficient of x power 0 in the expansion of 1 plus x power negative 8. And then negative 8C8 represents the coefficient of x power 8 in the expansion of 1 plus x power negative 8 as well. So this term represents like x power 0, x power 8. So x power 0 from here, x power 8 from there, and then you got 1 plus x power negative 8. Once again the same stuff, right? So this is going to be x power 1 from here, and then x power 7 from here. But the thing is, you got alternate negative positive. So for that, what I'm going to do is just I'm going to put a negative over here. So now think about it. Negative 8, negative of negative 8C1. What does that represent? That represents the coefficient of x power 1 in the expansion of this guy. And now it makes much more sense, right? yeah, I mean, this whole series is basically just the equation of x power 8 in the expansion of this thing, right? The Taylor expansion, that is. So it's gonna be like 1 minus x squared to the power of negative 8. Whatever is the expansion of this thing, right? You just want what? You just want the equation of x power 8 from here, which is like equation of x square power 4, right? So that's gonna be like negative 8c 4, and then you got negative 1 power 4, because x power 8 will be there in any case. We don't need to look at that. So yeah, it's just 1, and this is the thing. So it's gonna be like negative 8 times negative 9 times negative 10 times negative 11, 4 of these guys, then you got 4 3 2 1. So that completely becomes positive. Just got this thing. Yeah, okay, so this cancels and this cancels, so it's gonna be like 30 times 11, so 330 would be the answer. I don't know whether or not this is correct, but right, I mean, this is a very crude idea at this moment. I really don't know if there's any more details about it that I missed, or some wrong assumptions that I made. I don't know. But if this answer is correct, then that would be basically saying that, hey, we can actually generalize this to a lot of different questions, and maybe a lot of questions which were basically impossible without this method would now become possible, right? And yeah, wow, I didn't think that this question would make me think so much, but it did. And honestly, it's amazing. I just discovered this weird, way of solving this, and it doesn't rely on the usual algebra that we do, right? So, yeah, very unique and also very powerful, I would say, because it can convert these changing n values to a not changing n value, which is right, makes everything easier, doesn't it? So, I guess we should stop. See you guys in the next video. Yeah, bye.